Hey YouTube, welcome back. Today we'll continue our series in system design fundamentals. Today we will talk about the message queues. And in the previous video we talked about the data centers and why they are important to make sure that we can serve users globally in different locations. Today we want to talk about the message queues and why we need them and what they are actually. So at the beginning, let's just talk about what is a problem from the simplest reason. Let's just delete this data center. No, let's just delete all of this. Delete all of this, man. Yeah, great. Oh, no. And let's just add this on like that. And yeah. Can I make this one like red so it will not get... Okay, so why we need message queue from the first place? What are message queues? So a message queue is a communication mechanism or technology used in distributed systems. Why do we need them? So let's just imagine that we have server 1, and this server 1 is doing a specific task, okay? And when server 1 is with the tasks when server 1 ends with its task, it will send a new requests or like the results of this task to server 2. Okay. And when server 2 got the results from the server 1 and start to run a new task. And after that, when server 2 ends its task, it will send the results to server 3, okay? Basically, what is happening here? Like, it looks quite smooth, but we have a big problem here. What if one of the servers has a problem? For example, maybe timeout, maybe it was too slow, maybe it has some sort of problem. Maybe server 2, if server 1 had this problem, server 2 will not be able to get the results. Therefore, there is a lot of servers. Like, imagine that we have this relationship between 6-7 servers. All the other servers will fail in this specific task, and there is this way in communication between servers. It's easy to be destroyed, or it's easy to be failed. So how can we solve this problem? We introduce something we call a message queue. Okay, so sorry. So a message queue let's just give it I want to make it first, it should be like that, and I want to give it a special color. Yeah, this is good. This good color. This color looks quite colorful. So instead of these two, instead of them, they are talking with each other directly, we use a message queue, which will be something like that. The server 1, when server 1 has a task and it ends the task, it pushes the task to the message queue, and server 2 will get the results from the message queue directly, and if there is no results, it will not get anything. And in the same will happen between server 3 and server 2. So basically, and instead of communicating like that, they will just to go here, and after that, no, okay, I guess it will be better to do it like that. Yeah, this one, it looks quite messy. And yeah, so basically what is happening here, that server 1 has a task. When server 1 finishes this task, it will send it to the message queue. After sending it to the message queue, the server 2 will pull from the message queue, and when the server 2 finish the task, it will push it to the message queue of that is responsible to that connected with server 3. So basically server 2 is no longer waiting for server 1 to finish its task. Basically what server 2 is doing, that it just search in the message queue, do we have a task or not? If there is a task, okay, let's just execute this task, otherwise let's not do anything. So it's a way better, more, it's way more efficient way in communication. So basically the message queue is a communication mechanism, as you can see, or a technology used in distributed system to enable the exchange of message between different software components or system asynchronously. It helps decouple the sender of the message, which is the producer, for the receiver, which is the consumer, or like the publish and publish consumer also the same, allowing them to operate independently and at their own pace. So basically a message queue is a durable component it's stored in memory that supports asynchronous communication. It serves as a buffer and distribute asynchronous requests. The basic architecture of a message queue is simple. Input service called a producer publish model, create message and publish them to the message queue. So basically server 1 will create a message and publish them to the message queue. And other services or servers called consumers or subscribers connected to the queue and perform action defined by the message queue. So for this one, this is a publisher, consumer, publisher, consumer, things like that. So decoupling makes the message queue a preferred architecture for building a scalable, reliable application. With the message queue, the producer can post messages to the queue when the consumer is unavailable to process it. The consumer can read messages from the queue even when the producer is unavailable. Consider the following use case. Your application supports a photo customization, for example, including copying, sharding, and maybe sharpening or blurring, stuff like that. Those customizations tasks take time to complete. So basically, web servers publish photo processing jobs to the message queue. Photo processing workers pick up their job. For example, let's say that we have this one. This one. It just maybe like decode the message, and after that, this one is resize the message, the photo, and this decode the photo, and like let's assume that. So when basically the photo processing workers pick up jobs from the message queue. Let's say we are editing photos here, so basically they pick up the photo from the message queue, the photo job from the message queue, and basically the producer and the consumer can be scaled independently. When the size of the queue becomes large, more workers we can add them. Basically, each message queue has workers, and the workers they can work with it. However, the thing that we can talk right now here, that let's say that this represents a photo updating mechanism. So basically this one is decoding the photo, this one is resizing the photo, and this one is merging everything together. So basically right now if server 1 is unavailable, server 2 doesn't care. Server 2 only care about the tasks in the message queue that need to be executed. So basically each server here it's independent by itself, and this is what makes the message queue one of the most important components when it comes to distributed systems. So basically how the message queue will work, the message queue will be connected with the web servers. Let's just put it here, and I want to make it to be the size, and can I make it bold also? Yeah, and let's just put this here, and I guess it'll be better to and basically no, let me just put this away like that and take this one here, and yeah, can I make it different color like this one? Yes, I can. Okay, it works for now. So basically, in conclusion, the message queue is a communication mechanism or technology used in distributed system, and it makes sure that the exchange of the messages between different software or components or tasks helps. It basically helps to decouple the sender and which is the sender of the message, which is the producer, from the receiver, which is the consumer, allowing them to operate independently and at their own pace, their own pace. So this is what the most important thing about the message queue. And after that, we talk about I guess the message queue also it lives in the data center. Oh, sorry for that. Let me just bring the message queue like here. Yeah. And okay. So the message queue has a specific important component that works with it. Let me just give me a minute. So basically, we have something called workers, and these workers have a specific task. So the workers and the message queue are closely related components in many software systems and distributed applications. Workers are processors or threads responsible for processing tasks or messages, and message queues provide a means of distributes and managing these tasks or the messages. For example, the web server have a task, it sends it to the message queue, and when it sends this to the message queue, what happens here is that, can we just put it here? I want to put this on like, hey. Basically the message queue will fire and will send all the tasks to the workers, and the workers will be executed. So basically, when the message queue is filled up with tasks, we can extend it with new workers. So let's just add it like that. Can I push this one like that here? So it will be no. Yeah, let's just push it, make it like that, and this here, and the cache here, and the workers be here. And let's just see how this will work. Okay, it doesn't look bad after all. It doesn't look bad. Okay. So basically here, the producer and the consumer can be scaled independently, and when the size of the message queue become large, we can add more workers. Like more workers are added to reduce the processing time. However, if the queue empty most of the time, the number of the workers can be reduced. So basically, what happened here, that when the servers have a specific task, they send it to the message queue, and the workers pull this task from the message queue and start processing it. So yeah, this is I don't know, but I don't like the. Okay, it will looks like that. Okay, let's I guess it will look like that. I guess it's not bad looking like that. So yeah, that's it. This is the message queue and how we need the message queue and why it's quite important. So let me just drag drag. Okay, let's just put here, and I want to copy this one and put it here. Okay, it's bold, but I don't care that much, to be honest with you guys. And let's just put this one here, so it's a description, a good description for it, and make the color white. And I love to take my time in organizing the things here, because without organizing, it will be like quite a mess and it will be hard to understand. Okay guys, that's it. Okay, that's it. I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in future problems.